All right, number 16 starts a different style of problem. It says write g of x in terms of f of x. Okay, so we want to just know in a basic way how these things changed. Okay, I'm not asking you to do it in words, I'm asking you to do it with equations now. And this is that next level thing that you're going to have to start seeing, especially with advanced algebra and even when you go into your college algebra classes. What this is g of x equals, and we want to write now, instead of writing a big old equation out, we just want to write what happened to this f of x function. Well, from here to here, we see this negative sign popped up directly on the x. So you have to document that in this way. It would be f of negative x. So we just take that negative sign and stick it right there with the x like it happened in the transformation. Okay? Number 17, same type of problem. We want to write g of x in terms of f of x. So whatever happened from f of x to g of x, we have to record that. Well, I see that this plus 5 showed up right next to the x. And so again, we're dealing with something happening right next to the actual x. Well, that means we have f, open up those parentheses, and we have our x, but this time we had a plus 5 tagged along. So you record that as such, okay? G of x equals f of x plus 5, and then close those parentheses off. Because what changed is this happening. The plus 5 right next to the x, so we record it as such. Number 18, we have that g of x equals. Again, we document what changed. This negative sign became a positive sign, and we had no number out here out back, and now we have this plus 2. So we have to do a negative sign in front of our f of x because that negative sign changed all the way out front. It didn't change on this x variable. It changed all the way out front, so we show that it changed all the way out front of f of x. The x is all by itself in these parentheses because nothing about the x changed. And then the plus 2 is out on the end, so we have a plus 2 out on our end. This is another example, kind of like number 15, where it's actually a small mistake in the problem if you start looking at the higher level mathematics to it. This change in sign right here would actually change both of these, so it might be recorded a little bit differently, but as far as the scope of this class, this is what I would expect you to know. Also, I will make sure no error like this happens on the test itself, okay? Number 19 and 20, we're just talking about end behavior. We have to do end behavior with these graphs, okay? So you're given a graphing calculator, that's what you need to use. Clear out whatever else was in there. We've got negative 8 times 4 raised to the x power. We press zoom 6, we don't know what kind of crazy graph we're using last, and there's our graph. Remember, end behavior is just talking about left half and right half. We learned that it always starts out with x as it approaches negative infinity. This means left half or left side. X approaching positive infinity. That's our right side. And we want to know, what does y approach as we do these things? So we look at the left side of our graph. As we go to the left, this is leveling off. And it's leveling off at that horizontal asymptote. Well, that horizontal asymptote's right here on this axis. It's at 0 on our y-axis. Remember, this is all in terms of y, in terms of up and down. So this levels off at 0 on this axis, which means as we approach negative infinity, we approach 0. It's going to get closer and closer and closer to 0 without ever hitting it. The right side, as we travel to the right on our graph, as we travel to the right, we see that this is going down, 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 down. That's what we're always answering is what is it doing in terms of our y values? Well, this one's going down, 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 and it'll never stop going down. So it's going to negative infinity. 20 is asking the same question, so I go ahead and set it up as x approaches negative infinity, and as x approaches positive infinity. We're then asking what's happening to our y values. That's what end behavior is asking, okay? So now we need to type in this absolutely crazy equation, but thankfully our graphing calculator can graph it for us. So it is 5 times 1/2 alpha y equals enter. You could also put it as just 0.5 or 1 divided by 2. Either one works. And then we're raising it to the x, and I believe it was plus 2 power. Don't forget to arrow out of there and do the plus 1 that's on the very end. So that's a big, crazy equation, but our calculator can graph it just like it would any other thing. So we go zoom 6, and we wait and watch our graph pop up. Okay, that one came all the way down from out of here and then leveled off on the right side. So when we're talking about the left side of the graph, as we go to the left, we see that it's going up, 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 and it's never gonna stop. So this time our left side approaches positive infinity. That's all it's asking is this is left side, this is right side, okay? So the right side of our graph is the one that's doing something interesting. It's flattening out. It's not gonna keep on going down forever, it's flattening out, and it's flattening out at a specific y value. So if I'm on my y-axis, I look, and if I go up 1, that's where it's flattening out at a positive 1, okay? Remember, where it flattens out is our asymptote. That number out back tells us our horizontal asymptote. This one didn't have 1, number 19, and so it was 0. That 0 has to be one of our answers, which means this 1 also has to be one of our answers. The other one's always an infinity, either a negative infinity or a positive infinity, okay? So if you can figure out which side it's flattening out on, the left or the right side, then you know the other one, you just have to look to see if it's going to positive or negative infinity, all right?